Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at grade 12 financial mathematics, specifically for only grade 12s, okay? The formulas that I'm going to talk about in this video, they are only specified for the grade 12s learners, okay? So now, let's just dive into it. In grade 11, you did what is this? Compound formula, simple interest formula, depreciation using a straight line, and all of that. Okay, yes. But now, in this video, specifically for grade 12, we're going to be looking at annuities. Okay, what are annuities? Annuities are amounts of money, okay, that we need, or rather, large amount of money that we, whether we invest monthly or we borrow money for a particular trip or whatever thing, you'll see exactly what are annuities. So let's look at the first one, the future value. What is the future value for? What is it used for? To use future value, you need to be, this is for savings. Okay, it is for savings, pensions, uh, trips maybe, trips, and etc. etc. Is it written like this? Yeah, etc. more. And then, how can I use the condition for me to use this formula? What are the conditions for me to use this future value? How will I see if I'm using the future value? This is the first one. Okay, it should be for the savings, pension, and trips and all of that. The second one, the second thing that I need to be aware of is that there should be regular payments. Regular payments. What do I mean by regular payments? It means now each and every month or each and every quarter or each and every semi-annually, you need to put money inside the bank, okay? So you need to have regular payments. Uh, unlike a compound formula where you save 10 rand now and want to see how much you will have in 2024, or rather, let me say 2024 is a previous year. In 2030, you want to see how much you have. No. In this case, it means you're investing 10 rand, 10 rand, 10 rand, 10 rand, 10 rand until the last day that you're going to be collecting your money. This is the type of another a hint to see that you're going to be using future value. It should be regular payments. And then, uh, yeah, those two things are very, very important. Those two things are very, very important. And then, how is this formula outputted now? We have a formula that says future value it is equal to x 1 plus I to the power of n minus 1, all divided by what? By I. Okay. Now let's talk specifically about what is f. What is f? The f there, it is the amount, let me say accumulated amount being saved, being invested. Invested, yeah, being invested, yeah. This is the accumulated amount being invested, okay? Or you can call it whatever you want to call it. But actually, it is the money that you will finally have at the end of the investment, okay? And then what is X? X in this case it refers to regular payments, okay? The X refers to the amount that you will be regularly doing payments. It refers to the amount that you'll be paying regularly, actually. So it is regular payments. And then I, as we know, it is the interest rate, okay, which is calculated by saying you take the one that you are given, divide by 100, okay? And then remember you will be given the rate. This is the interest. And then the N here, this N, please take note. Please take note. This N here does not refer to the number of months per se. months per se, it refers to the number of payments. Number of payments that you're going to do. Okay. So the number of payments that you're going to do. Very, very important. Number of payments to date. So I have X, I, and I feel like we are cool. Now, it's very easy to use this formula. They might say to you, in this video, I do not necessarily want to do calculations and all of those. I want us to explain a few things. Okay, so you'll be told that Sipho is saving 100 Rand, okay, 100 and okay, 550 per month for the next 5 years. He is planning to buy a laptop in 2031 when he goes to university, and all of those. Calculate how much Sipho will have after 5 years at an interest rate of this one, compounded quarterly, monthly, and all of that, right? Yes. Now, what I want you to take note of is that, okay, this N refers to the number of payments, and how will we calculate it? We will say it is the number of years multiplied by the period. What do I mean by the period? The period refers now to, the period can either be monthly, quarterly, or semi-annually. Semi-annual is the same as half yearly. Okay, half yearly. Oh, yeah. So if it is invested for 5 years, you have to multiply that by quarterly. Quarterly, you multiply by 4. Monthly, it is 12. Semi-annual or a half yearly, it is 2. So you multiply by whatever period that you are given thereof. Okay. Also, after the interest there, after getting whatever the decimal there that you get, you have to divide the interest by the what? By the period thereof, basically. Okay. Yes, that's that. Now, I feel like I can have one example of this so that we see exactly what we are dealing with, and then see some other things that might happen during the payment and all of that. Okay, let's have this example now. It says Mukheseng wants to save up money for an overseas vacation after he graduates from university, right? And then says he opens a savings account and immediately deposits 500. After this, he continues to deposit 500 at the end of each month for 4 years. The interest rate remains fixed at 8% per annum compounded monthly. Okay, how much will he have in the savings account at the end of 4 years? Now, before I answer this question, I need you to take note of this. Okay, when you are doing these type of questions for future value and all of that, you need to take into consideration the value of n. Okay, the value of n, it is very, very important. What do I mean by that? Let me explain this. Now, when you open, okay, after opening a savings account, after opening a savings account, there are two things that should happen. First one, do not start making payments immediately. 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 Aibo. The first caution. Do not start making payments immediately. Number two, complete the number of payments. Complete the number of payments. Yeah, complete the number of payments in time, in given time. What do I mean by that? Not early or late, but exactly in time. Okay. I hear that after opening a savings account, the first condition, I should not start making payments immediately. The second one, I should complete the number of payments in given time, not early or late, but exactly in time. What do I mean by that? I'll start with this first one. This first one. I'm going to branch it again into three parts. Okay. If you're, let's say you are given an interest monthly, and then we will consider also quarterly, we will also consider semi-annually. What I want to explain is here, monthly, it is that you will make your payments each and every month, right? But but after opening a savings account, okay, let's say you open a savings account and then you are given an interest rate of whatever compounded monthly. What should happen is that you should not pay until 1 month after opening this account passes. Let's say, what do I mean by that? Let's say you open your account on the 1st of January. Okay. Okay. Let's say for all of them, you open on the 1st of January. When should you start making the payment? When should you start making the payment? For the monthly, since when you're gonna pay each and every month, you should skip the first month. What do I mean by that? It means you do not pay immediately after opening an account. What you do, you start depositing your money a month after opening. What do I mean by that? It means you need to start investing or saving after a month, a month after opening your account, which is on what? On the 1st of February 2026. This is the normal. You need to do this. This is okay. If you do that, everything is okay. When it is quarterly, remember quarterly, you will make payments. This is 12. Remember, this is 4. This is 2 times. So remember, quarterly it is made out of 3 months. Again, the first 3 months, January to March, April to June, July to whatever. So here on quarterly, what do you need? For if your interest rate is quarterly, it means now after opening your account, you need to skip the first 3 months. Okay, you need to skip the first 3 months because will be paying each and every after 3 months. Okay, January to March, your first payment, then April to June, your second payment, July to September, your third payment, October to December, your fourth payment. Can you see 1, 2, 3, 4? So hence you are saying it is 4 like that. So you need very, very importantly to pay after 3 months. 3 months after that. What is 3 months after January? It means you'll skip February. This is 1 month. Okay. You'll skip 1 March. You'll also skip what? 1 April 2026. And then you start making payment on start making payment. Okay, let me do this. You start making payment here. And then here you start making payment after skipping February, March, April. You'll start doing payment in what is this month? May. Okay, let me write it like this. Okay, I think it's more month now. Okay, skip January, you pay in February. Okay. So you skip January, February. Oh, actually, let me do this. I'm lying. You have to skip January, okay, the normal first month. The first month you have to skip 1 January. You skip January. Let me write it here. You skip January, you skip February, you skip March, and then you start making payment in April. Here, remember you skipped what? You skipped January. Here you skipped January and start making payment in February. You skipped only 1 month, then you make a payment. Here you skipped 1 to 3 months. Can you see? You skipped what? The first 3 months. Here you skipped only the first 1 month. Then it means here you should start making payment on the 1st of April 2026. I hope that's clear. And then on this one, semi-annually, since well semi-annually you get, or rather you save or you deposit twice in a year. It means every after 6 months from January to June, and then from July to December. So it means now if you open your account in January, it means you should skip all the first 6 months and start making your payment in what? In the 1st of July 2026. Let's confirm. You skip the January, you skip February, you skip March, you skip April, you skip May, you also skip June. And then can you see 1, 2, 3, 4, 5, 6? Then you start making payment in what? In July. Okay? Very important. I'll write it here. For this one, monthly, skip 1. Here you skip 3. Here you skip 6. Okay? The common one you will see it is this 2. Common one you'll see it is this 2. Okay, I hope that's clear. But now the question arises, okay, this will also apply or in loans, okay? I will not repeat this. This also applies when we're going to talk about present value, the loan and all of that. It's the same in terms of payments and all of that. But what if there is a deviation? What do I mean by deviation? Breaking of rules. Let me say breaking of rules. Deviation, it is when you change what's supposed to happen normally. Okay, we know that normally you are supposed to pay what blah blah monthly and all of that. What if now on the first one, okay, start paying immediately. Let's say this is the first one, this is the second one, the third one. On the first one where your interest is compounded monthly, how is it going to be affected? What are we going to do to account for that affection? Okay, so what we're going to do, I think affection is the wrong word that I used there. What I'm going to do is I'll calculate my normal number of months. Let's say you want to do it for 5 years. The number of payments is going to be 5 multiplied by what? Let's talk about immediately. It's going to be n, it is equal to 5 times 5, it is the number of years, multiplied by monthly, it is 12. This is normal. But now when he pays immediately, it means instead of skipping a month, he will start in that month. So we have to add that month into the payments because normally we do not account for that month. We start accounting from February. Okay. When we start counting from February, when you start making payments immediately, it means you'll have to add 1 to your payments. Okay. Yes. This is what will happen. You add 1 to your what? To your payment. I hope that's clear. On the second one, what if you start immediately? When you start immediately on the second condition, it will be 5 multiplied by 12. But now we need to add the months that you're supposed to skip, but rather paid. Okay? So you're supposed to skip 3 months. So we're going to add those 3 months that you decided to be I don't know a what, and pay them and pay during that one. They give you a break when you decide to pay, then we're going to account for that. Is that clear? So also here, n is equal to 5 times 12 plus, you're supposed to skip 6 and you paid. Oh, I think here I'm lying. Oh, yeah. You're supposed to skip the first 6 months and then you'll pay in July. But when you pay in July, you pay once for a quarter. You pay in July and it will accommodate what? July to December, since well you make only once in 6 months. Okay. So you just add what? Six. So not six, one. Why am I adding one here? Because you are supposed to skip a first what? Um, the first, what is this? What do you call semi? 6 months. Yeah, you're supposed to skip 6 months, and then but when you decided to pay that one, okay. That's basically that. That's basically that. I hope it's clear on this one. Let me confirm something. On quarterly, if you're supposed to skip, oh no. Okay. On quarterly, I know that you're supposed to, we actually know that you're supposed to skip the first 3 months, okay, before making the payment that will accommodate the other 3 months. Okay. So we'll add one also here. Why? Because, okay, let me say from January to March, you are supposed to make no payment. Okay. Then you'll start from April to June. This will be your first payment. You are not paying on April, May, June. On April, we are making the first payment. It will last to July. And then the other payment you will do again, it is July. It will last to August, September, to September. This is your second payment. Unlike monthly, do not confuse quarterly with monthly. Okay, monthly is that each and every month. Okay, but can you see here? You pay after 3 months. You pay in April, and then you'll pay again in July, and then at the end of September again, which is now October to December, you make another payment, third payment. Okay, so this is what is supposed to happen, basically. Okay, yes. You start immediately, and then you are affected. What if now you end early? Okay. When you end early, let's say uh 2 months, let's say uh the first condition, you end 2 months early. When you end 2 months early, it's gonna be 5 multiplied by 12 minus 2. Okay. But when we do that, we will have to, after doing this, on your value there, remember when you end 2 months earlier, but you cannot collect your money. Okay, you can stop making regular payments 2 months earlier. Then you do not collect your money. Your money will be stuck in there. Okay, your money will be stuck in there until the normal payment, or rather the normal period ends. Okay, so when another 2 months here, your money will be inside the bank, but it won't stay only there. It won't be just staying in there. What will happen? What will happen is that for that 2 months, your money will grow. Interest divided by 12 will grow from how much? For 2 months. Okay. The money that is in there, let's say you're supposed to pay for 60 months again, or make 60 payments. And then when you stop at 58 making payments, the amount that is at 58, we will just compound it with an interest. It is gonna gain interest for 2 months, that amount that you get thereof. Okay, yes. The minute you subtract, okay, the minute you subtract, remember to put the bracket I divided by whatever interest period, and then multiply by, or to the power of whatever the months that you skipped or did not pay as such, per se. Okay, yeah, I think is supposed to be cool. Let's let's have now an example that we had thereof. And then move on to present value, and then move on to other things and other things here. Actually, I'm gonna only do one example for each, and then all the other things you'll get them when we are looking at exam questions. Okay, yes, I don't like doing examples from textbook and all of that because yeah. Okay, now we can go back. We can go back now and say, now that we are exposed to such information, let's see if you can apply that information now. I will repeat this statement. Mukhesen wants to save up money for an overseas vacation after he graduates from university. Again, he opens a savings account and immediately, very keyword, immediately deposits 500. Okay, remember that immediately has an effect. That immediately, we do not want immediately. It's going to have an effect on the number of payments. Deposits 500. After this, he continues to deposit 500 at the end of each month for 4 years. So there are regular payments, okay? So he's going to deposit 500, 500, 500, 500 each and every month. So we can use, this tells us that future value, it is very correct to use on this one. Okay, first thing that I take note of is that future value is applicable here. Why? Because this particular person is going to be doing what? Regular payment of how much? Of 500. And then at the end of after this, he continues to deposit 500 at the end of each month for 4 years. Okay, the interest rate remains fixed at 8% per annum, compounded monthly. Okay, now I want you to teach you something. X you have again, it is the regular payments 500, and then interest, you are told that it is 8%. You're gonna need to divide 8% by 100 first. You're gonna get 0.08 again, and that 0.08 you need to divide it by whatever this is here. If it is compounded monthly, that 0.08 you need to divide it by 12. Okay, do not simplify this, leave it as it is. And then when I look at my formula again, what is left, remember I'm looking for F. Okay, I'm looking for F. What I'm left with, it is N, very important. The normal N is supposed to be the number of years. It is 4 multiplied by, gonna make payments each and every 12 month again. So multiply by the period, of the interest, okay, which is the period in which you're going to be making regular payments. It is monthly, so it's going to be the number of years multiplied by whatever this is here. This in here, this one should match this one. Very, very important. When you multiply N with whatever period, it should match the one you divided the interest with thereof. But now, there was the keyword thereof, there was an immediate payment. Okay, so let's say he opened in January, 1st of January, but we know that the first payment is supposed to come from 1st of February. This was supposed to be the first payment, but now he decided to make the first payment here. So can you see he added this month? So we have to add one there. Add one there for immediate what? For immediate payment. And then I can substitute there and play with mathematics. And then regular payment, it is 500. Then 1 plus my interest, it is 0.08 compounded quarterly, so compounded monthly, which I divide by 12. And then N is supposed to be 4 multiplied by 12, it is 48, plus 1, it is going to be 49 now. Instead of the normal 48 that was supposed to be made, now it is now 49. Divide by interest 0.08, all divided by how much? By 12, and then you will get that amount of future value to be. I do not want to calculate it, but for the purpose of this, I'll just do it. Okay, and then I need to power that to the power of 49, and then minus 1. Please take out the formula exactly as it is from the formula sheet, guys. If you're not so sure about the formula, please do that. I get something like 228,862.79. So this is the amount that Mukheseng will have at the end of 4 years, and after, when he goes to or after he graduates at university. But now number B says, at the end of 4 years, Mukheseng stops making payments. Okay, I mean, it's normal. I get because Vele was supposed to make payments until for 4 years, and then after that he will stop because it. I mean, he's supposed to collect his money basically, but now the actual fact is that he leaves the money in the account for another 2 years. Okay, while he completes a postgraduate degree. So I want you to take note of this. This amount, this one. Remember, Mkheseng was supposed to collect. Okay, was supposed to go to the bank and collect this money. But instead of collecting this money, Mukherjee decided to do what? Decided to say, okay, I leave this money in the bank for another 2 years. Okay, for another 2 years while he completes a postgraduate degree. Okay, then the question is, how much money will he have at the end of these 2 years? Now, what you should question yourself is Mukherjee doing regular payments in these 2 years? The answer is no. Okay, Mukherjee just took this money and then it's like Mukherjee took that money and invested into the bank and waited for it to grow and collect it after 2 years. Okay, so in this one we will use this a it is equal to p plus 1 I to the power of n. Why? Because Mukherjee here is investing money and then waiting for it to accumulate at the end of whatever years. Okay, so we want to know after 2 years how much Mokgeseng will have. So we want to know after 2 years how much Mokgeseng will have. My A will be equal to what? Will be equal to this. Sorry, my P rather. My P will be the amount that is actually inside the bank. Okay, that he decides to leave inside the bank, and then my interest remains unchanged. So my interest remains unchanged. It's going to be 8%, which is 0.08 divided by 12. And then the number of years, this is the number of years or number of months. Okay, unlike that one we refer to as number of payments when we use future value or annuity. So number of years, but we calculate it the same way. Okay, it's going to be 2 years. Okay, multiply by how many months in there? 12. Remember I said this 12 should match this 12 thereof. Beautiful, right? Yes, and then we get this is how much? 24, and then we can calculate this. 28, 862,79, 1 plus my interest, it is 0.08, all divided by 12 to the power of 24. And then I can beautifully calculate that amount to be how much? 1 plus 0.08 divided by 12 to the power of 24. Okay. Then Mokgeseng at the end of those postgraduate what he will have 33,852,82. This is the amount that Mokgeseng will have at the end of that 2 years. But take note here, we cannot use future value. Why? Because there are no regular payments. Remember, condition for future value is that you need what? You need regular payments. Very, very, very important. Very, very, very important. Okay, it's very, very important, guys. Okay, let's now look at present value. Okay, here's a present value. Now, how do we see if we're going to be talking about present value or what? First one, they will talk about loans, okay, or they will talk about. Okay, normally they refer to when they talk about loans and all of that and that, but there is this one that student struggle to identify, especially when the equation comes, and it is always a challenge to majority of the students. And I do not blame them, but I'll try to explain it in the possible way. Continuous withdrawals. Continuous. Guys, you're gonna excuse my English. Continuous. Continuous. Yo, where? Continuous withdrawals. Withdrawals. And then this is the condition. Should be a loan or continuous withdrawal. Continuous withdrawal, it is okay, I'll explain it. And then also here they should be regular. Instead of payment, okay, payment or installment. Installment. Remember, installment, it is when you have taken a car Again, taking a car, you have to pay an installment of that much, a house, a what, a bond, all those. And then now let me talk about, okay, this one is straightforward. A loan, it's either you borrowed a loan for your house and what, or you indeed took a loan from the Volkswagen car, what, or or whatever the case, whatever the case. The one that is very, very mistakenly where students mistake it with the future value, it is this one, continuous withdrawals. How do we see continuous withdrawals? When I save, when I save 1 million, let's say I save 1 million. Okay, let me say I deposit 1 million into the bank, into the bank. And then the banks give me an interest of whatever 12, okay, let's say 10% compounded quota, not quota, let me use monthly for purpose of explanation and better understanding. I deposit 1 million, and then let's say I deposit 1 million on the 1st of January. I like 2026, I don't know why. I deposit 1 million on the 1st of January 2026. Ne? And then after depositing this money, at the, okay, remember I'm giving an interest thereof. I'm giving an interest of whatever monthly. Okay. If I'm giving this interest monthly, what I'm expecting to have is that, okay, I'm expecting this money to grow. Or this is not, I'm not doing, take note of this. I'm not doing regular payments. I deposited a large amount, which is 1 million. Okay. And then they will, the bank will give it interest there as it grows for whatever those number of years. It will have an interest growing on it. But instead of just letting it grow, avoiding to use compound formula, each and every month I withdraw 20,000 each and every month. Okay. I deposited 1 million, and then each and every month I'm withdrawing 20,000. Okay. But remember, this money, as I'm depositing it, this money will grow inside the bank. After growing, let's say I deposit 1 million today. Next month, it will have received an interest. Maybe it will be 1,200,000. Okay. And then I take out 20,000. The next month, it will grow. The amount that is inside the bank will get an interest again. Let me make an example like this. I invest 100 Rand, okay, on the 1st of January. On the 2nd, so on the 1st of February, my money will get an interest. Let's say an interest received, it is makes my money to become 120. And then after receiving an interest, I withdraw 10 Rand. Okay. Can you see that on the 2nd of February, when I withdraw 110, the money inside the bank will now be how much? 110. So that 110 will get an interest on the 1st of March. It will get an interest, and then it will grow to something like maybe 130. But and I also take the 10 Rand. So the money will be 120. And then on the 1st of April, that 120 received an interest, maybe it becomes 140. And then I take out 10 Rand again, it becomes 130, and then continuously like that. So I want you to take it like this. Ne? I want you to take it like this. Take it as if you are the one loaning the bank. Okay? Take it as if you are the one loaning the bank. It's not, you're not doing that, but take it like that. Take it as if you are the one loaning the bank with 1 million. Okay, you are loaning the bank with 1 million, and then the bank each and every month will pay you how much? 20,000 each and every month. It is not actually the fact, okay, but assume that you are loaning the bank with 1 million, and then each and every month they're going to be giving you 20,000. So hence this falls under what? Present value. Okay, you deposit 1 million, but each and every month you withdraw 20,000. It's like you gave a loan of 1 million to the bank, and the bank will pay you 20,000 at that particular interest rate thereof. I hope that's clear. I think I've emphasized it enough. Now, here's a formula for present value. P X is still 4. Okay, I look at that. Instead of the original one, remember on this one we had 1 plus n. So on this one, we say it is 1 minus 1 plus I to the power of negative n. For a loan, it is negative n. And then divide by I. Please always consult your formula sheet, guys. Or your, what is it? Yeah, formula sheet that has formulas. P, it is the present value, which is money owed, or money to settle. Sorry, money owed or money to settle. X, regular payments, or in this case, I can say regular installments. And then I, it is just an interest, and then N, it is number of payments, regular payments. Okay, and um, IN and X is the same for both future value as well as present value. So P, you just know it is what and what again. Okay, okay, okay. I think I leave it like for now like this, and then let us do one example based on this one. Only one, only just one example. Okay, only one example. Okay, here is an example. It says Jenny wishes to repay a loan. Very important. It is a loan, present value of 150,000 by means of 16 equal quarterly payments. Okay. We have here the present value because this is the amount that you want to settle, 150,000 by means of 16 equal payments. And it is 16 equal payments. Equal quarterly payments, very, very important. Starting 3 months from now, I'll come back to that statement. The interest rate on the loan, it is this much. We have I compounded quarterly. If it is compounded quarterly, it means now you're gonna pay how many times? 4 times a year. Okay, each after 3 months you pay, after 3 months you pay, after 3 months you pay, after 3 months you pay. Okay, so my N, okay, it is 16 sharp, quarterly. Now, if I'm given an interest quarterly, when should I start paying? Remember, quarterly, you make payments each and every 3 months. Okay, let's say you are given a loan today and you have to make, you are given an interest compounded quarterly. How many months are you supposed to normally skip for you to complete the normal cycle? Remember this. If it is compounded monthly, you have to skip whether it is savings for future value or present value, you have to pay the loan back. If it is monthly, you have to skip the first month. If it is monthly, if it is quarterly, you have to skip the first 3 months. Okay, you have to make a payment 3 months after. Okay, and then if you're given semi-annual, you have to make a payment 6 months after. But in this case, it is quarterly, so you need to miss or skip 3 months. Is it the case now? Let's go back. Starting 3 months from now, then it's good. This is good because he started 3 months from the time the loan was given to him or her. Okay, so this is good. There's no addition of 1, there's no subtraction of 3 or whatever. So this is perfectly fine. Okay, sharp. And then when I look at my things here, okay, I will say for number A, present value is equal to, remember the formula, do not forget the formula, 1 minus 1 plus I to the power of negative n. Please check your formula sheet, guys. Very, very important. You do not want to find yourself making mistakes of the things that you are given. And then P, it is how much? P, it is the money that you need to settle. It is 150. What do they want? A, calculate what Jenny's quarterly payment will be. Hence, N we do not, okay, X, we do not say it is monthly payments. We say it is regular payments. So in this case, the payments are done monthly. So quarterly. So it is quarterly payments. So we want the value of X. P, it is 150,000. X, it is what I'm looking for. And then 1 minus 1 plus the interest, it is 2.5, 21.5 rather, which is 0. You need to divide that by 100 first, which is 0.215. And then divide that by how much? Quarterly. Quarterly, it is 4. Okay, it is 4. Quarterly, it is 4. Remember that. Quarterly, it is 4. And then we are already told that is 16 equal payments, so 16. Oh, but remember, negative 16. Okay, divide by I 0.215 divided by 14. Someone here, instead of dividing by that one, he or she will write 21.5% divided by 4. You need to make sure when you punch your calculator, this percent it is present there. Because if you just do 21.5 only, it's wrong. But if you can say 21.5% divided by 4, then it's good. I mean, we cannot penalize you. Oh, actually, the teachers cannot. So when you calculate X there, in actual fact, I get something like 150,000 divided by that bunch, which is 1 minus 1 plus 0.215 divided by 4 to the power of negative 16. Very, very important. I missed that negative, I'm out. 0.215 divided by 4. Did I say 14 there? It's actually 4. Okay. If I'm correct, I get something like 14,212,35. This is the regular payments that who is this guy? Jenny is gonna make, or a girl. Is it a lady or a guy? I'm not sure. I'm not so sure. So yeah, this is that. 14 rand 212.35. Done. The number B part of this question says. The number B part of this question says, calculate the total interest that Jen will pay. Remember, if you take a loan of 20,000, when you repay it, you'll pay more than 20,000, almost double sometimes, especially for houses. For houses, you can find yourself a house that is worth 800,000, okay? Or let me say a house that is worth 1 million, you'll end up paying like 2.3 million without realizing, because they give you a long term, and the longer the period that you pay or you settle your loan, the longer the interest, or the higher the interest, rather, the better English. So if you take a loan for 20 years and you took a loan of 100 rand, just be ready to pay uh just be ready to pay something like 750, because maybe you'll be paying little by little 50 rand or whatever thing, but yeah, just be ready. So yeah, if you can, even when you are buying a phone, if you can, just make sure you pay it for 12 months, maybe here, 12 months. Okay, if your phone was supposed to be worth 3,000 for 12 months, you'll see that maybe you will have paid 3.6. But if you increase to 24 months, it will be something like 4,100 maybe. You will pay 4,100 when you calculate. Okay, because why? Check, when they say 12 months, they will say maybe you pay per month, you may pay 500. Ne? But when the months increase, they will reduce the monthly payment. They will say maybe it is something like 430. But in actual fact, this 430 that you think it is less, it accumulates in 24 months, and then it becomes larger than the 512 months. Hopefully it's clear. But you can consult with those who are doing accounting and financial mathematics and financial what taxation and all of those. People are doing things outside here, but I did physics and mathematics. I cannot talk about the accounting one. But yeah, then the total interest that Jenny will pay is that Jenny will pay this amount per month. So let's see that amount. After, if let's see when Jenny pays this amount for 4 years, it's actually 4 years. If you were to check here, we are given, remember, n it is equal to number of years multiplied by the period. Okay, so the n it is 16, and then the number of years you do not know, and then the period it is quarterly, and quarterly will make 4. So years is going to be 16 divided by 4, which is actual fact 4 years. Okay. So now let's see if Jenny pays this amount for 4 years, how much it will grow to. So we're going to say A is equal to P into 1 plus I to the power of n. We want to see where this amount is going to be how much if he pays it at that interest. To the power of 16 here. Okay, just remember it is 16 payments. So when I punch my calculator beautifully there, it gives me something like 1 plus 0.15. Hopefully I did not make any mistake and included a 0. 16. So in actual fact, it's going to be 332,844.85. This is the money that at the end of the 4 years of that loan, he will pay. But remember, the initial loan was there's something that I did here. Just a bit. Okay, maybe let me return back to my calculations and then do this. Okay, let me go and say 150,000 again. Sorry, a little bit. Let me quickly confirm my calculations. There. Okay, why am I using the compound formula? So sorry about that. Remember, he will make let's say amount paid. Ne? This is the amount paid. I don't know what's got into me. Amount paid is gonna be this amount 14,1200. I will. He's going to pay this amount for how many times? Okay, he's going to make payments of this amount how many times? 16 times, right? And then we actually get something like 14,212, 14,212, 14,212,35 times 16. And then this amount is something like, okay, 22,227, 397.60. This is the amount that he will pay. But now the loan was initially how much? 150,000. Can you see now what he paid is longer than what the loan was supposed to be. So the interest interest paid is going to be the amount paid, right? Subtracted the loan value. So we agree that it's going to be 227, 397.60 minus 150,000. So I want you to see how large this amount of interest is paid off. So it's very, very, very amount of money. Can you check? 77,397.60. So this is the amount of interest he paid. Can you see? It's almost half of the amount that you initially it's actually above half of the amount that you initially loaned. So it means you're going to pay the 150,000 plus half of it. So that's how cruel loans can be. So yeah, guys, that's life. Let's move on to outstanding balance. Okay. What is outstanding balance? From the way it should make sense, because it is the balance that is outstanding, that is supposed okay, that you still need to make payments of. Okay, so outstanding balance, in simple terms, amount needed to settle the rest of the loan. Or amount that is still yet to be paid. Yet to be paid. All right. Remember, you get a loan, and then in that loan, your loan is 150,000, but you won't pay 150,000, right? Your loan is 150,000, and then on that 150,000, the bank, what the bank will actually do, will give that 150,000 in interest for maybe, let's say, for 5 years. And then when you have to pay that amount, okay, you have to pay that amount until that 5 years. So in actual fact, you're gonna pay the loan amount plus its interest. Okay, exactly. Now the outstanding balance, we calculate it when, let's say, you are supposed to make 60 payments, and then halfway through, you are after 48 payments, you want to see how much is left for you to pay. Okay, or how much is still yet okay, how much you still owe. Okay, so in actual fact, we say, okay, how do we calculate outstanding balance? We say for outstanding balance, it is the amount that the loan, remember, the loan, you're going to take the loan, right, of 150,000. And then the bank will calculate an interest of that 150,000 for that duration of the year. We're going to subtract it with the future value. Future value formula. Why future value formula? Because the future value formula will tell us or how much you've been in paying, okay, or how much you've been what is this, okay, your money that you've been paying back to settle the loan, how much it has accumulated to become, or how much it has accumulated, okay, in actual fact, how much you've paid. Okay, yes, this is the first formula. The second formula, you can use this, you use it on the day. Okay, on this one, n is going to be equal to the uh months already paid. Months paid. Okay, when you use this one, is n is going to be for the months already paid. Let's say you are supposed to end at 60, and when you are somewhere at 82. So when you use this formula, you need to say, okay, from here to here, what is the outstanding balance? So it's going to be 32. Okay, but okay, let me retain this. Okay, let me remove it actually. Or you can use this formula. Outstanding balance, it is equal to present value. But in your present value, what is it that you're going to include? You're going to include your N is going to be the months yet to pay remaining. The months remaining. What do I mean? If you're supposed to pay for 60 months and then when you're still at 32, when you calculate outstanding balance for using present value, you will take the remainder of the months here, which is in actual fact 28. So you will see how much money should be paid in these 28 months. Okay, if you use this one, you say, okay, for the one that I already have, how much have I already paid and how much am I still owing? Okay, yes. Let's have an example of that so that you understand actually what do I mean by that, or by these two formulas, and how true are they? How do they correlate? Is it true that I can use both of them? Okay, but only changing the n, the of. Let's confirm that. Okay, let's have a look at this example. It says Sibusiso took a loan of 250,000, right? He makes monthly payment of 5,000 on the loan, and interest is calculated at 15% per annum component monthly. What is the outstanding balance on the loan after 3 years? Directly after the payment at the end of 3 years. So this one, you cannot use the other formula. I'll show you. We only use this one. Okay, I want you to get used to this one. Okay, the solution for this one, we want to calculate what outstanding balance. Okay, outstanding balance, remember, is going to be what? The compound formula. Okay, this is the interest charged to date minus your future value. Minus your future value formula. It goes like to the power of, this is P, to the power of N minus 1 all divided by I. Or you can say initially OB, it is equal to A minus F. Okay. Now, outstanding balance is going to be P, it is going to be the 250, okay, 1,000, plus I is going to be the interest, which is 15%, which is 0.15, divide by what? Divide by compounded monthly by 12 to the power of what? Supposed to be paid 3 years, okay? So N is going to be 3 times 2. So N is going to be 3 times compounded monthly, 12. So it's going to be 3 times 12, which is how much? Which is in actual fact 48. I'm lying, 36. 36, okay? Minus, actually the N here and the N here should match, guys. Should match. It should match. This one, payments, it is making regular payments of 5,000. And then 1 plus the interest. Actually, this part, the interest should also be the same, guys. It should also be the same. And we actually know it is 31. Wait. Okay. And then I just need to divide that, all of those things, by the interest, which is 0.15 divided by 12, guys. And then I can actually get my outstanding balance. Outstanding balance should be 250,000. 1 plus 0.15 divided by 12, the power of 36. Actually, I'm going to tell you how cruel the bank can be, guys. Ne? I will tell you how cruel the bank can be, especially in terms of loans. You should be very, very cautious and very careful when you take loans, guys. Like the machonesa that we at gas we use. You do not pay now. Actually, if you're supposed to pay and you do not pay, the money increases. Okay? The money increases. When you're supposed to pay, the outstanding balance, it is 16,165 or 08,43. I want you to check this, guys. This person initially owes, not own, owes, okay, the bank 250. But can you see now, after paying 5,000 for 3 years, look how much is still left for him to pay. Like, it's not even half of the amount taken the loan for. It's not even close to half. So this is the effect of the interest, guys. So this person is still owing this amount, even after paying after 3 years. Like, yeah. What I wanted to stress out is this, guys. When you are paying out your loan, let's say you're supposed to pay your loan from T0, no, you start making your loan payment from, let me say, T0, T1. You start making it here. And then you're supposed to end at T16. Somewhere, somehow, at T22, 23, and then 24, you struggle to pay. Ne? The last payment that you did was on T21. This is the last payment you did. And then you continue again at T25 up to T60, guys. This is what the bank will do. Ne? The bank will say, okay, we see that you have paid from T1 to T21. Okay? You are paying. Let's calculate the outstanding balance. The bank will say, let's calculate, okay, you paid from T1 to T21 and then skipped the first 3 months due to financial difficulties. Okay, due to financial difficulties. and then you regained your form and then continued after T25 to T60, the bank will not call you and say, Papa, you did not pay. The bank will not do that. In actual fact, what the bank will do will say, huh, so you think you can fool us? Cool, we'll see who's the smart one. The bank will say, okay, let us calculate, Hore, you already paid how much here after T21, how much you were left. Actually, this English is becoming too much now. The bank will say, let's check how much you paid and how much is it left for you to pay. Okay. So the first thing that the bank will do will say, okay, let us calculate the outstanding balance at time T1. Okay, after paying time T1, how much is left for you to pay for this remaining months? And then, okay, after seeing that the outstanding balance, the money that is still left to pay, it is this much. The bank will say, okay, well, now you know that you still have this amount to pay, but you decide not to pay for the next 3 months. What we will do, we will penalize you. What do you mean I will penalize you? It means the bank will say, okay, on the money that you still need to pay, we will charge an interest. You won't pay that money. We will make this money, the outstanding balance that you still owe, we will increase it. We will put an interest on it. Okay, we will put an interest on it for whatever those months you missed. Let's say this, in this case, it is 12, but I do not want to put 12. We'll just put whatever. If it is quarterly, you'll put 4. The bank will say, we will put an interest into the money that you still owe. So instead of owing, let's say you owed, you were left with 220,000 to pay. The bank will say, okay, that 220,000, you will no longer pay it. You will pay the amount that is increased, because when I decided not to pay the other month, let's say it is monthly here, it's going to be interest divided by monthly. And then to the power of the months that you missed. How many months did you miss? You missed 3. And then this will be your new present value. This will be your new P that you need to pay. Okay? This will be your new outstanding balance. Okay? This will be your new outstanding balance. And then when you want to calculate the rest or reach this part, you will use outstanding balance like that. It's basically that. Okay, so just take note, if someone skips some certain months, calculate the outstanding balance for the last payment he did or she did before taking a gap from the financial screens. Yeah? And then after doing that, calculate the interest that the bank will charge that particular person for not paying for that particular month, okay, for 3 months or 2 months. And then you continue from there with whatever the question asked you. Okay. What is it that I wanted to mention again? Yeah, it's basically that for the outstanding balance. Let's move on to the last one. I don't know how the video is long. I think it's something like an hour or 30 or 2 hours. I don't know. So let's look at the last one, which is a sinking fund. I like that one. It's straightforward. It has marks. Sinking funds. What exactly are sinking funds? Okay. Sinking funds, now, if I were to explain it in simple terms, we'd say it is now the amount that you actually need, you will need in the future to buy a certain product that you already have, but you want to replace it. Okay, let me make a simple example that you will maybe understand. Let's say you're a student you just entered university in 2025 in this current year, and you bought a Huawei or HP laptop that is worth 20,000. Okay, and then they tell you that the guarantee or warranty, I don't know the word that they use, it's gonna last. Okay, let's say the very same laptop that you use, HP, that you bought in 2025, you want to replace it in 2030 with the very same laptop. you do not change the very same laptop you are using. You want to change it and buy a new model of it. Okay, the very same one, but a new one from the store. Okay, what happens is that the laptop when is it with you when it is with you, it depreciates in value. What do I mean by that? It depreciates. It means now if you were to sell it, it will you will sell it at a cheaper value. All right, this is what we refer to as depreciation. But the very same laptop at the at the store will rather do what? Will increase in value due to what? Due to inflation. Okay? Due to inflation, the very same laptop that you bought now in 2030, it will be worth more than what you bought it with in 2025. Okay? And then for you to buy that laptop, you will need some certain amount. Okay? So let's say you bought that laptop for 100 rand and then bought, okay, 100 rand. And then these are the things that will occur. It will depreciate, lose value, and depreciate to 25 rand after 5 years. It will depreciate to 25 rand. And the very same model will inflate at the store. It will have an inflation. Remember, each and every good at the store, each and every year, it increases its value again. Make an example of bread. We in 20, I don't know which year. Okay, I assume that we are peers or more or less close to being peers, or yeah. In When you were doing grade 5, you bought bread maybe ka 14 rand, but now you buy bread ka 20 something. So that's what we refer to as inflation. So similarly, the very same laptop that you bought ka 100 rand, after 5 years, it will be worth maybe something like 170. Okay, and then you will need to replace that that laptop with a new one. So can you see that the amount that you will need, okay, if you were to want to buy a new laptop, you will sell this one at 25 rand and then see how much you will actually need. Okay, what you will need for a new laptop will be 170. 170 minus 25, which is an actual fact 145. So you will need 145 for a what? For that laptop. Where are you gonna get that 145? What you will do is that you will open a sinking fund. Okay? You will open a what? Open a sinking fund. Sinking fund, how do I open a sinking fund? Do regular payments. Open a sinking fund and invest using future value formula. Future value formula. Then you are done. You are done. So it means the amount that I need to save for will be the one that I need. Yes. So when you use sinking fund, your F will be the amount that you need by saying the amount that your laptop will be worth. Okay, the amount that you want to buy the laptop with after 5 years minus the amount that you bought your laptop with. Okay, then that is the amount that you need to save for. Okay. Oh, so in simple terms, for me to open a sinking fund, okay, for me to open a sinking fund, I will need these two things. Okay, I will need firstly to calculate the inflation. Okay, first calculate the inflation. Oh, secondly, I'll need to calculate the depreciation value of my laptop. Depreciation value. Right. Okay, cool. And then thirdly, I will need to do what? Open a sinking fund. Okay. How? The question is how? By saying my sinking fund is going to be F, open a sinking fund, how? Is going to be F is equal to the inflation minus the depreciation. This will be the amount that I need. depreciation. So, oh, this is the amount that I will need. Okay, good. Then I hear you. Everything will be the same as that one. Let us have a reminder for inflation. We're gonna use this formula. A is equal to P into 1 plus I to the power of N. Where, okay, another question that you should take note of, inflation, they only put it once a year. So you cannot use the formula. There's no monthly, there's no quarterly, there's no semi-annual for inflation. It is annually, once a year. So the interest here, do not divide this one by 12 or whatever. Do not multiply this by 12 or whatever. You just write I as it is, N as it is on this formula. As well as the depreciation formula, we have two of them. Okay, let me take this a little bit down here. We have two of the formulas used for depreciation. Two formulas, yes. How? When they say on straight line method, you're going to use this formula. A is equal to P into 1 minus IN. Okay, on a straight line method. You're going to use the simple interest, but with a minus, because when it depreciates, it will lose value. But when they talk about reducing balance, so balance method, the reducing balance method, it is the compound formula, but with a what? With a what? With a minus. Yeah. Okay. Not here at on N. Here inside. Okay. So these are the two questions that you should be aware of. Are we ready for an example? I think we are. I think we are ready for an example. What am I doing? We are ready for an example. Let's have a look at that example now. Here's an example of a sinking fund. Okay, let's just confirm by the statement if it is a sinking fund now. It says a company purchases an excavator for 900,000. The value of the machine depreciates at a rate, very important, the value of the machine depreciates at the rate of 10% per annum on reducing balance. Cool. They tell us that the company wants to buy a new excavator in 10 years' time. Then they say inflation is estimated at 7% per annum. Okay. Then they say to us, the excavator will be sold at scrap value after 10 years. It will be sold. To purchase a new a new machine, the money obtained from selling the old excavator will be used. Again, a sinking fund is set up to finance the balance. Actually, we know that the money that you sell the excavator with after 10 years, it will not be enough to buy what? To buy you that excavator after 10 years. In actual fact, what you'll need to do is that you will need to take that money and add it with some amount that you need to save. Okay, so how can we open that? The saving that we need, we refer to that as the sinking fund. Okay, so they say the interest rate for the fund, it is 9% per annum of the sinking fund. Okay, they tell us a sinking fund, it is set up to finance the balance. The interest rate for the fund, it is 9% per annum. Very important, compounded monthly. Okay, and they tell us, very important, they tell us that the first payment into the sinking fund is made immediately, and the last payment it is made at the end of 10 years. How much must the company pay into the fund per month? I will explain this again before I continue. They bought this one, a machine for 900,000 again, and they want to replace that machine with the same model of that excavator after 10 years. After 10 years, what will happen is that they will sell the excavator, the old excavator or the old machine with the money, okay, at the scrapyard. And then the money that they will get, they will see that it is not enough to buy the excavator, the new excavator. So they will do what? They will, instead of waiting for them to sell it. Immediately after buying this the old excavator, they will open a sinking fund because they will have calculated or exactly how much it will cost the excavator after 10 years. So they will calculate they will save a certain amount inside the bank. Okay, so that amount that they will be saving each and every month inside the bank for the 10 years. It is what we refer to the sinking fund. The sinking fund is going to help you to do what? It's going to help, say, sinking fund amount plus the amount that you sold. Okay? Amount that you sold the what the machine with after 10 years, and then it will now be able to pay for what, to pay for the new machine. Okay, and these are the another important thing is that the first payment into the sinking fund is made immediately. So remember, when you open a savings account, whether it is the sinking fund or what, and it is compounded monthly, you need if let's say you I feel like you know this, but I'll repeat it for the last time. If you open the sinking fund on the 1st of January and it is compounded monthly, you need to skip the first month. It means you need to first start making first savings should come on the 1st of February. Okay, this is normal, and you should end after whatever year, 10 years. But in actual fact, this is made, okay, the payment is made immediately. So when it is made immediately, it is made immediately here. So it's going to affect what? The number of years, or rather the number of payments. So in actual fact, the number of payments for the sinking fund, take note, and for the sinking fund is going to be 10 times 12, but we need to add 1. Okay, only for the sinking fund. When we now look at the formula for sinking fund, we need to take caution of this part. Now let's calculate. Remember, the first step, it is to calculate what? The inflation. Formula for inflation, sorry. Formula for inflation, P is equal to 1 plus I to the power of n. P, it is this amount, 900,000. 1 plus interest, it is, can you see? It says interest, inflation is in estimated at 7% per annum. There is no monthly, there is no quarterly, there is no nothing. So we will just write 0.07 here, how exactly it is. And then the number of years will just be 10. Why? Because whatever that I divided with here, I multiply with. Since when I did not divide by anything, I do not multiply by anything. Very important. In actual fact, here I divided by 1. It means I multiply by 1. So there's no need to write that. Then I use my calculator and confirm how much I get. 900,000, 1 plus 0.07 to the power of 10. It will cost 1,770,436,222. Okay. Now I need to calculate, I'm going to sell it by how much? I'm going to sell it by how much it is depreciation. When I select by how much it is depreciation, how do I calculate depreciation? P, it is equal to, I need to check what kind of method did I use for depreciation. They tell me it is what? Reducing balance method. Remember, for reducing balance method, it is this one, 1 minus I to the power of n. If they said on straight line method, I was going to use this one, 1 minus in. Very, very important. Please know those two. Depreciation, P, it is how much? 900,000. I want to know it will value how much after that one. The interest, it is different. Depreciation and inflation do not use the same interest. It is 10%. Because if that was the case, I mean, things will 10%, right? So I'm gonna just say 0.10%, okay, which is 10% divided by 100, and then to the power of 10. Let's see how much this value, this car depreciates with, or 2 So this car will now be, you're gonna sell that car 313,810,5961. I'm keeping this decimal because it is not my final answer. Okay. Okay. Take note of something. Take note of something. The amount that this car will be worth, it is bigger than the one that you bought it with in that year. Yeah, how? Okay. So it's now worth 1 million. Okay, almost double, almost clearly like almost double, because double of 9,000 it is 1,800,000. So it is almost double. But when you sell it with less than half of it. It's actually a third. One third is like you are selling it with like 33%. You're gonna get 33% of the actual value of it. So can you see that? So we need to open what? A sinking fund. But how much will I know I need to save for? Which is my sinking fund. I need to save for how much? The sinking fund, it is the amount that I need to save for. How much is that amount? How much is that amount? Okay, that amount is going to be what? The inflation value minus the depreciation value. And then let's see how much I get. Inflation value, it was 1 million, 1,770,436. Okay, let me write it. 1,770,436,222 minus the depreciation value. It is 313,810,5961. So I'm going to say 1,770,536,222 minus that amount. Aha, Mudimo. I get something like 1,456,625,626. I'm not rounding off because it's not my final answer. So this is the amount that you will need to save for. This is not the amount that you will buy a car with. The car, you need to buy the car with this amount. But since when you will be having this amount, remember you will sell it with this amount. Okay? Okay. So you will need something to add on the value on your money that you got after selling it, which in this case it should be this how much. But you cannot just sell a car or that machine and then instantly you have 1 million. You need to save for that 1 million. That's where we introduce what? The future value formula. It means you will be saving for this amount. You are not saving that amount. You will be saving for it. Okay. So you need to do regular payments from the day you buy this one, so that at the end of 10 years and after selling it, you have something that you have saved. You collect that something you have saved, you add it with the money that you have sold your old machine with, and then buy a new machine thereof. Okay. So the question is, how much must the company pay into the fund? So you need to know that each and every month you should put how much. Okay. So how can we get that? Each and every month I need to put how much? Future value. X 1 plus I to the power of n minus 1 divided by I. And I know that I need this amount. At the end of 10 years, I will need this amount. Okay. Which is in actual fact 1,456,625, 628, 626, sorry. It is equal to, I'm looking for the X, and then it's going to be equal to, let me try to do that, X, and then it's going to be 1 plus the interest. Each and everything has its interest. The interest for the sinking fund, it is 9%. Can you see that? The interest for the sinking fund, it is 9%. Actually, let me do this. I need to highlight the immediately part. They tell us in blue highlighted, the fund is set up, the interest rate for the fund, it is 9% per annum, compounded monthly. So the minute they introduce the word monthly, it means my interest, which is 0.09, needs to be divided by 12 because there is some words monthly there. And then the number of payment, which is n is gonna be 10 years multiplied by the monthly, which is 12. But now, since the payment was made immediately, remember, every time when they say immediately, you need to add 1 because it is done immediately, and it was monthly. So it's going to be, in actual fact, our n is going to be 120 plus 1. It is 121. Let me just confirm. 12 times 10 plus, okay, plus 1. Yes, it is 121. So this particular person is going to make 121 payments. And then I need to minus 1. And then I can divide by that interest again, 0.09 divided by 12. And then I can actually get the value of x. I don't know where to write it because I've run out of space. Let me see if I can try to squeeze this at the top somewhere here. Okay, let's see if I can try to squeeze that. Just a little bit. Just be patient with me. Move this a little bit to the top. And then, yeah, let me take this one again. So sorry for the time consuming. Already the video is long and I'm making it more long. So sorry about that. Just want to create, let me leave it. It's gonna cause us problems. So X, when you do your mathematics there, you will get that it is 1,456,625,626 divide by what? By that amount, divide by all of this. So when I do that and then wrap up the video because I'm done, it's probably long, divide by 12, the power of 121 minus 1. And then I'm going to divide that by 0.01. Please confirm with me on your calculator that I did not do any silly mistake. So per month, this particular person, these people will need to save this amount. So each and every month, you need to save this one for the next 10 years for you to reach this amount. Whew. So yeah, guys, that's all from me on this financial mathematics video. I couldn't upload what are these exam questions without thoroughly going through this because yeah, it's a struggle for a lot of students, the financial mathematics, and yeah, let's try to catch up with it. So thank you very much for joining me. Hopefully you had a very good time with me, even though it's long, but hopefully you managed to get all the information that is necessary for you. So thank you very much.